Hi, this is Silva from Innovatrix Repairs. Today we'll be making a video about a motherboard repair. So what we have to work on today is an iPhone 7, and the phone won't turn on, and we'll kind of go over a little bit how the phone works. So the phone is already deassembled, and as you can see, we have the screen assembly right over here, and then we have the frame of the phone, a battery, charging port, the vibrator, rear camera of the iPhone 7, and over here we have the motherboard, which is what we're going to be working on right now. And next we'll be switching over to the microscope view, and we'll show you what it looks like in there. I'll kind of explain a little bit how it works as well. Something else we'll use is this voltmeter. So I already did some testing on this phone, and I know for sure that there's a short on it. So you could imagine a short in electronic, a little bit like a water pipe that's busted open. And so if you're trying to get water from one end to the pipe to another end of a pipe, if there's a hole in it, the water will leak and it won't get there. And essentially that's what we're hunting for. So over here, I can zoom out a little bit and just kind of show you the logic board. So here we have our connector for the screen and a connector for the home button. This is our battery connector. We'll be taking some measurements from that in a minute. After that we have this here, which is for the charge port, and then we have the SIM card tray is kind of hidden in here, and this is where the CPU is under this plate. And afterwards we have this connector, which is camera assembly right here. I believe this might be for the that one would be for the rear camera right over here. And if we go all the way over here, this one's for the side keys and power button. And then if we flip the board around, if we go over here, so this is one of the top part of the board and where most of the components are. After that we have this big chip here. That one's the memory chip, so all of your pictures and all that gets stored in this chip. And then there's quite a lot of different chips over here. I'm familiar with this one over here. So that one is called TriStar. That one takes care of essentially charging your phone. There's another one that I'm fairly familiar with as well, which is the Tigris chip, which is right over here. So essentially that's a bit of an overview of the board, just really quickly. So what we're looking at first is this battery connector. So I know that this phone has no power, doesn't turn on, and one thing I'm going to do really quick is take what's called a diode measurement. So diode measurement is going to inject some voltage from this probe all the way to that probe, and it will inject the least amount of voltage required to go from point A to point B. So we'll just go from one end to the other, and I'm guessing you guys probably can't read that, but this says 0.45 volts. And if we go check the other side from the other polarity, we also get 0.45 volts. And I know from experience, typically when the power rails are okay, they should be sitting, one would be at port 1.5, and then if we reverse it, it would be at around 1.23, just kind of depending on the model of the phone. So this is too low, which means that there is less resistance than there should be. But before you can use the battery voltage, it needs to be it needs to be filtered out. And so it goes from being the battery voltage to what's usually known as VDD Main. It's the main power rail that supplies most voltage across the entire phone, and quite often when VDD main or VCC main is shorted to ground, you're gonna have that lower resistance on your battery line. So if we look here, all of these red dots are all connected on that line, VDD main. So I am gonna go and use this component right here. So now I'm gonna bring up the microscope view, and this is that component I was showing a while ago. And typically I can do that same measurement that I've done with the battery line. If I'm right and this component, or this line rather, is shorted to main, it's going to require zero voltage, because it's essentially just a straight path to it and there's no resistance. So we're going to go ahead and take a measurement. And sure enough, I have a reading of 0.001, so that's essentially zero. So it is definitely shorted to ground. So everything that's red is connected on VDD Main, which means technically, as long as that component is also connected to ground, any one of those could be shorted. And our job is to find which one. And the component that is shorted to ground should generate heat as current flows through it. And I'm gonna connect the negative end of my power supply to the ground of my board. And then the next thing I'm gonna do, well, is connect this probe to the power supply. This is not necessarily a how-to guide. There's a few things you gotta know before you start injecting voltage inside your logic board. You need to make sure that you're respecting the amount of current that's allowed through the line, so you don't burn out traces. You don't want to put too much voltage, and obviously you want to make sure that you're not contacting anything else that you're not supposed to. With a data line, this technique won't work for you. I think that motherboard repair at this level is fairly new in the industry, so I just kind of want to help to demystify it a little bit, just so at least that if you're a customer and we talk to you a little bit about having to repair your motherboard, it's maybe not as scary as it might sound. To help find the heat, one way that I like to do is use some freeze spray. So we're going to freeze the motherboard. Once again, you kind of want to know what you're doing before you start freezing your iPhone 7 motherboard. So I can see the areas melting, but I'm not seeing anything that's really sticking out. And I did end up finding the shorted capacitor, and I made a recording just off the camera so you guys can see us finding the shorted cap. There won't be any audio, but I'll still show the clip. So I already took off the capacitor. It was right over here. So all that's left to do now is just to replace it. But I can show that we don't have a short circuit anymore on VCC main, and the first time around we did this on VCC main, we had 0 volt, meaning that there was no resistance at all. So if I go ahead and put the red probe on ground, and this probe on VCC main, I now have 0.33, which is typical for VCC main, so that's a good reading. So now we just have to replace that capacitor with a new one, like so, and put a little bit of flux here, and put my iron on, and I'm just going to go and pin the pad, so that means I'm just going to go and put some fresh solder on it. Zoom in a little bit. So there's a bit of solder that went on the shield. That's not a big deal. I can take that off after too. Just gonna clean it up, and you can see that now they're nice and shiny. Okay, so now I have my new capacitor, which is this guy over here. And just to give you guys a bit of a perspective, here's a dime, and there's the capacitor. Just give you an idea of scale. Put some flux again, bring down my capacitor. And there it goes, back where it belongs. That's kind of hot. I'm just going to go ahead and pick up a little mess of solder I made here. There we go. And I don't know if you guys remember in the beginning of the video, I took some measurements here. I'll try to show it to the camera, but I'll read it out loud anyways. And this was our battery connector. It's the first thing I measured. And if I go here, from here to here, I get from here to here. One end to the other, we get 0.9. So the iPhone 7 is a little different from the other one, so it'll start at 1.2 or something. The other ones usually stays there. The iPhone 7, the requirement's going to go up and up until it reaches open line, and that's what it does now. And if I go check on the other side of it, I got my 0.4, so I'm pretty happy. Okay, so this is the following day after I've worked on the iPhone 7 from yesterday, and we did find the what was causing the short in the motherboard, but when we were trying to power the phone on, it still would not boot completely, meaning that it wouldn't turn on. And it had a bit of a strange booting pattern that we can see from the current consumption from the power supply. After I'd done some testing, I've come to realize that the phone would turn on fine when the screen was not connected, and as soon as I connected the screen, the phone would not turn on anymore. So I did some digging around a little bit, and after looking a bit, I came to the conclusion that this IC, which is a chip that takes care of the display, might be bad, considering that this capacitor, which was the one that was shorted, is connected directly right next to it. It's possible that maybe that chip might have failed originally, which then caused that capacitor to fail as well. But I did end up replacing it off camera, and the phone does work. I'll show you the phone afterwards. What I will do is just do the chip replacement on a donor board that we have here, just to show you what that looks like as well. It's kind of a neat process, and a bit more interesting than just replacing a capacitor. So so just to disclaimer, so this is another iPhone 7 board. It's not the same one that we're working on, but we will do that chip replacement just to show you guys what we've also done to make the phone work. So I already took the chip off on this one, so the chip should be right here. And the chip that I took out from the good phone is this one. So this is the chip that was defective. It's got some flux on it, so it looks a little nasty right now. I can clean it up a little bit. So this is the chip that sends all the power to the screen. And like I said, typically whenever this goes bad, typically the phone can still boot even if the screen is connected. So that was new to me, that it would cause it not to turn the phone on. And we're just gonna take that chip. Once again, that chip is bad, and this is not our original board. But we're just gonna take this chip and we're gonna solder it on this board just to show you what we did to the iPhone 7 to our customer. So the first thing we got to do is take care of all these balls. So those are solder balls. This is how this chip connects to the motherboard. So if I flip the chip around, you see all the little balls underneath the chip. So those are solder balls, and then they need to be lined up and resoldered on those solder ball on the motherboard. So there we go. So I'm just going to move the chip out of the way for now. And we're going to go ahead and make this great again. So there. And we're going to clean it up so we can have a look at what we did. Okay, so this is coming along all right. So the goal here is just to make everything nice and even. So I'm just going to put some new flux on it, and then I'll use some hot air just for it to take its shape again as it should be. There we go. So that's done. I'm just going to clean up the work area again. There. So now the next thing we need to do is prepare our chip. So this is the chip we're going to be soldering back. Right here. And we're going to go ahead, flip it around. And whenever we solder these chips on the board, since there's a lot of connections, everything needs to be kind of raised a little bit, so we need to go ahead and kind of reball this, is what we call, and make them bigger and even. So first thing we're going to do is just kind of take care of the old one that's already there. Oh. There we go. Just like this. And we're just gonna go over it with our iron like that. We're gonna clean it up. this year's a stencil. So there's a stencil for all kind of different chip or ICs. We're gonna find the one that we want, which is this one here. And go ahead and line it up with the chip. Lining it up. Grab some paste. Clean it off. Put some more, a little bit here. There, that should do it. So we'll flip it around again, clean it up. So if we flip it now, try to bring it in view. You can see all the balls, they're all even and they're raised as well. A while ago they were a little too flat. Here's the board. Put the chip there. And we'll go look at our software to see what orientation we need to put the chip in. And now that we know that, go ahead and put some flux. So, maybe I can bring the light down a little bit. There. The chip is pretty much in place. I've got some flux underneath it, so now I'm just going to go ahead and melt the solder. And voila, the chip's in place. Or it looks a little dirty just because it still has flux on it. I'm not going to bother cleaning it up. I'm actually going to take that chip off afterwards just so I don't think that it's a good chip. And it was just to show what we had to do with the iPhone 7 to fix the last problem. And next I'll show you the phone turning on. Okay, so we got the turbo paste on it. So the next part is we got to put this shield back over this CPU. Over here, and I usually like to do this with the help of the microscope. So I'm just gonna go ahead and realign this as best as I can. So the shield is on it, and now I just gotta solder it back. Solder. Okay, so now we're gonna reassemble the phone and test it out. So this is the iPhone 7 board from our customer. And we're gonna get started here with reassembling this phone for our customer. And you can mess up your motherboard by putting the wrong screws in the wrong spot. We're gonna set up the section for the antennas, which is over here. There we go. And we'll connect back this antenna. Put the rear camera back. Just double check it. Connect back my antennas. There goes the screen. And there goes the battery. Just need to put this plate back in there. There. So that's all of our screws. So I'm just going to close the phone up. So we're going to pop the top in first. Then snap the bottom, do the sides. And there we go. Last thing, I just need to put the two bottom screws over here. iPhone 7, I'm just going to turn it on again. And voila! Job is done. All that we need to do now is just to make sure that everything is working fine. So like I said, we're just going to be doing a full function test on the phone. And once that's done, we can call up the customer and let him know that his iPhone 7 is ready. So thank you very much for watching the video. I hope that you guys enjoyed it and learned something. This is Sylvain from Innovatrix Repairs, and have yourself a nice day.